Welcome back to our wireless radio series. In this video, we will continue with where we left off discussing wave modulation in Part 1. How does wireless radio communication work? Where we also discussed electromagnetism and how radio waves are transmitted and received. You can find the link to this video in the description. And now that we have a better understanding of electromagnetism and how radio waves are generated, let's continue with this knowledge of wireless communication in our Part 2 video, How Can We Improve Wireless Radio Modulation? In this video, we will discuss radio modulation, what is path loss and how to decrease it, line of sight propagation, path profiles, and path profile engineering. So what exactly is modulation? Modulation is a technique of converting and mixing data into radio waves by adding this information to a carrier or base signal. This is accomplished by a modulator in which mixes the data signal with a carrier signal. A carrier wave is a wave of constant frequency, like a sine wave. And as we have learned previously, the transmitter combines the modulated and amplified signals to the antenna, which is specifically designed to emit this signal to the air. The now modulated and amplified signal, which emanates from the antenna, propagates through the air towards the receiving station antenna, where the modulated signal is demodulated, separating the data from the carrier signal. So, in other words, modulation alters the shape of a carrier wave to encode the speech or sound and data information we want to be transported by hopping on a normal signal wave. A wave can be identified by its frequency, measured in oscillation per second, its wavelength, measured in units of lengths, and its amplitude, or power, measured in decibels or meters. This means the wavelength is inversely proportional to frequency, in that the longer the wavelength will result in a lower frequency, or the shorter the wavelength will result in a higher frequency. There are essentially three basic types of modulation: amplitude modulation, then there is frequency modulation, and finally, phase modulation. The difference between these modulation methods is how the carrier wave is modulated, hence altered. Let's talk about the first two types. Amplitude, or AM modulation, is where the amplitude of the carrier signal is modulated or changed in proportion to the data signal. And with frequency, or FM modulation, the frequency, or the number of times per second the wave changes direction, determines how the carrier signal is modulated or altered. Okay, now let's discuss how far a radio wave will travel or propagate, and what are the elements interfering or attenuates the signal, with a brief introduction to path loss. The transmitter radiates a signal having a specific power based on the size and type of an antenna. The signal as it travels begins to weaken or attenuate based on the environment and landscape the signal travels. The phenomenon known for how the electromagnetic wave weakens is known as path loss. Radio waves are not aware of the exact path to a receiver, and therefore, once transmitted, propagates in a direction of where antenna radiates the signal. But the receiver only captures a certain portion of the signal based on the power used at transmission, and depending on the different obstructive factors, such as distance or free space. Obstacles such as buildings and mountains, for example. As electromagnetic waves propagate and travel further and further away, the initial power at which the transmitted signals spreads out over a large area. In the beginning, the entire transmitted power is confined to a small spherical area or bubble. To illustrate the degradation of the signal, if the receiver is close to the transmitter, it will capture more power, and if the receiver is further away from the transmitter, the receiving antenna can only capture a smaller fraction of the transmitted power. There are several parameters involved with attenuation. They are distance, wavelength, and the transmit power. As we now know, the power of the signal reduces as the signal propagates. And so, just to let you know, the shorter waves, or higher the frequency waves, will experience higher attenuation. Path loss, or L, depends on distance and wavelength. The greater the distance means lower power to be received, and with the wavelength, attenuation is greater for shorter wavelengths. Power loss is the weakening of the signal no matter how much power is transmitted. This means, if the path attenuation is 20 decibels, it will affect a strong signal in the same way as a weak signal. However, if we transmit a weak signal and becomes attenuated even more, the demodulation of the signal becomes less reliable or even impossible. How can we overcome path loss? One way is to use an RF line-of-sight tool. It allows us to easily drag and drop blue and green markers at different locations. The tool then provides point-to-point line-of-sight information anywhere using Google Maps, for example. Check out this free online tool from SCADAcore. You can find the link to this tool in the description. The RF line-of-sight tool is very helpful in mapping long-distance radio communications for remote SCADA monitoring remote sites and data acquisition applications. The online tool considers antenna height and the topographical patterns of the Earth to calculate the line of sight of a radio path. What about security? Isn't this a concern with all this information transmitting out over free space? Yes, and wireless network security becomes a very important factor for IT and SCADA administrators to consider. Soon, the RealPARS video, Wireless Security on the Plant Floor Explained, will be released. Newcomers to RealPARS have free access to one of our online courses. You can take advantage of this offer by downloading the RealPARS app and selecting the first lesson of the PLC hardware course. Just like this video, the lessons are all high quality and also very easy to follow. Also, for a low monthly fee, you'll get full access to an exclusive library of courses on PLC programming and industrial automation topics, as well as new fresh-out-of-the-oven videos each and every week. These courses are all member exclusive and are not shared anywhere else on the internet.